Okay, welcome everyone, and good afternoon to the final presentation of the day. And I know we might be holding some of you back from drinks, but this is going to be so interesting that you'll postpone your drink start time by 10 or 15 minutes. I'm Dave Deptula, Dean of the Mitchell Institute for Aerospace Studies, and I don't think it's a surprise to anybody here that it's no secret that air power is America's asymmetric advantage. However, it's this advantage that has to be carefully stewarded. It's not a given. And over the past 3 decades, we've seen our capabilities, capacity, and readiness erode to the point where today the Air Force is the oldest and the smallest and the least ready that it's ever been in its history. Now, if we're going to win the conflicts of the future, these deficiencies have to be reversed. The Air Force must modernize its geriatric force, grow capacity, and ensure our air crews are well trained. So that's what our panel is here to discuss today. Key combat aircraft modernization efforts and why they're absolutely required in quantities that meet the demands of our combatant commanders. The reason is because American air power will make the difference between victory and defeat in any future fight. So let me quickly introduce our panelists to take a deep dive on the future of air power. I'm going to start with Major General, sorry, so long. Didn't want to demote you there, but Major General Joe Solo Kunkel. He's a director of force design, integration, and wargaming, Air Force A57. Brigadier General Jason Voorheis. Jason, on the other end down there, is a program executive officer for fighters and advanced aircraft, Air Force Lifecycle Management Center. Then there's Lieutenant General Dave Kooler Krumm, U.S. Air Force retired, Vice President, Business Development, Electronic Systems at BAE. We're fortunate to have with us also Tom Jones, President, Aeronautics Systems, Northrop Grumman Corporation, and Dan Gillian, Vice President and General Manager, Air Dominance, Boeing Defense, Space, and Security. So gentlemen, thank you all for taking the time to be here today. And we're going to kick this off with General Kunkel. So you're an F-22 pilot, and you came out strong articulating the need for the F-47. As a baseline for this conversation, tell us why is a combination of stealth, information dominance, and advanced EW an imperative for modern air combat?
Well, hey, Kooler did want me to add that he's an F-22 pilot as well, so, yep. All right, hey, I think before we have that very specific conversation about stealth and information dominance and EW, we probably need to raise it up a level and understand what air power brings to policymakers. And air power provides policymakers a decisive advantage. We want to ensure that our policymakers are negotiating from a position of strength. In order for them to negotiate from a position of strength, we need to have military options that achieve military objectives, and every military objective is focused on, or it depends on, air superiority. And air superiority in the future is different than what air superiority in the past has been. And combat success in the past was, platform level integration. If you had the best F-15 with the best AIM-120, that resulted in combat success. If you had an AMRAAM that had a fantastic air-to-air missile, that resulted in combat success. When we look at how the threats have evolved, the kill chains that we have to defeat to achieve air superiority are much more complex. And to defeat the complexity of those kill chains, you need system-level integration. And that system-level integration means that the entry point to go into combat and achieve the level of air superiority you need is going to depend on stealth, EW, and information dominance. Those are the entry points. If you don't have those things and utilize them together in a system, you're not going to be successful on the modern battlefield.
That's a pretty good succinct explanation. Jason, if you would, talk to us a bit how you and your team see this challenge from your perch at AFMC, because you're charged with stewarding much of this modernization effort. So how do you explain that this is a no-fail imperative, especially to our friends in Congress?
Yeah, thanks for allowing me to be here to represent the acquisition perspective. It's good to be here with Dan, my colleague on the Boeing side on a number of fighter programs, and Tom, who was a great partner from an industry perspective on B-21. I would say, the first thing as an acquisition officer, when discussing the imperative to modernize our air power capabilities, the first thing I do is make sure I'm tightly aligned with our operator friends who, like Solo and who, like General Krumm before him, are so articulate about what we need, why we need it, and in what quantities. General Kunkel owns the force design. He helps us prioritize the mission threads, and he talks to us about setting that performance baseline. So that's really important. With that said, from my acquisition perch, I would argue that today, and more so in the future as we go forward, how we develop our weapon systems will be just as important as what we buy and in how many in quantities we buy. We definitely need to reform the way we buy our weapon systems so that we can integrate capability faster, more affordably, and we can integrate, as Solo said, from a system of systems perspective across our joint and coalition force. There's no question our analysis shows that B-21, F-47, and even CCA are going to significantly add to the lethality of U.S. air power. However, more importantly, on those specific platforms, as a great exemplar, is that we're developing those systems differently. These systems are all being developed on the foundation of digital engineering. They're based on modular open system architecture and open standards. And in the case of CCA, we're also building that with an exportability by design mentality. And I would just say that the value proposition for modularity, open architectures and open standards is crystal clear. And I like to talk about those from three different perspectives. The first is from a capability perspective in terms of breaking vendor lock through those open standards, driving sustained competition, allowing for multiple vendors who can integrate different software on different hardware, unlocking innovation across our industrial base. From an agility perspective, isolating flight critical from mission software, which open architectures allows us to do, allows us to insert technology more quickly over time, driving that agility. And then finally, from a business case, not only on these 5th and 6th generation platforms, but on our F-16s and our F-15s, investment in open architectures really pays off in terms of keeping upgrades affordable and more rapid over time. So I'd just say, again, the value proposition is clear, and it becomes even more clear when we partner across the Air Force, our sister services, and our coalition partners to drive common open standards and architectures to get more effective interoperability from a CCA perspective, more C2 interchangeability, and then coalition capacity across our force. So for me, the future of air power, in my opinion, is not just about what we build, but how we build it.
Well said. Thanks very much. Kooler, Solo mentioned it, but let's jump into this in a little more detail, because as much as kinetic power matters in today's fight, the non-kinetic realm is going to make the difference between success and failure to a large degree in future conflicts. So what trends do you see with electromagnetic spectrum operations? That EA-37B obviously is huge in this role, but you're also on a lot of other aircraft, things like the F-35, F-15EX, and others. Your thoughts?
Thanks, General Deptula, and thank you, Solo and Jason, for reminding me I'm a has-been. That was awesome. So this goes back to how has the electromagnetic spectrum changed? And over the last 30 years, everything has changed. If you think about what we did as an Air Force, and even as a joint force, what we did was dominate the electromagnetic spectrum. We talk about the radars, the stealth, the jamming that we built. It was all designed to dominate the electromagnetic spectrum, to be able to go in offensively, survive defensively, and get the job done. The electromagnetic spectrum that we was so good at was kind of small. But now what modern technology has done, it's opened up that electromagnetic spectrum so that every part of the kill chain can be utilized in any part of the electromagnetic spectrum. And what that means is every part of the electromagnetic spectrum for anything that's going to go in the battle space, it's got to be attacking the spectrum and it's got to be defending the spectrum. And that's a really, really complicated task. And you're going to have to do this in collaboration, in concert, coordination between multiple entities. You're going to need some broad area things like with the EA-37B, but almost every single thing is going to have to either be supported or have its onboard support of electronic warfare so that we can retake territory back the adversaries tried to deny us from, employ the weapons we need to employ, and then safely egress back home. I think that's what EW has changed today.
Well said. Tom, there's still a few out there that claim that stealth is dead. I find this continue to be very frustrating because stealth is not a fixed commodity. It's a dynamic set of capabilities that constantly evolve, and quite frankly is an entry level to any kind of high-end spectrum of conflict. Now the B-21 is going to take this to an entirely different level. Could you talk a bit how you and your team are working to constantly evolve this capability?
Sure. Well, first of all, General, thanks for having me on the panel, and thank you for giving me a really easy question to answer without stumbling over security restrictions. You know, I think to start off with, I'm wearing my B2 pin today. Someone was asking me before the talk here, oh, you're wearing the B2 instead of B-21. So yeah, it's kind of been the summer of the B2 this year, hasn't it? And, you know, talking about the strategic optionality you get with Airpower, as, you know, General Kunkel laid out, what better examples do we have of the viability of stealth today than Operation Midnight Hammer and the successful use of the F-35s by the Israelis in the 12-day war, right? Bringing Airpower to rapidly change strategic situations. And, you know, I like to point out to people that, you know, that performance by the B-2, which was flying against still very sophisticated Russian radar systems, was from 50-year-old stealth technology, right? Which is just incredible that a system designed that far back in time can still perform. A lot of times when I get in these philosophical discussions about the future of stealth, you know, I try and remind people, you know, the history of warfare has always been about measure, countermeasure, countermeasure, and stealth is exactly the same way. In fact, we don't even really use the word stealth in Northrop Grumman anymore. We talk about survivability, really, because it is, as you said, not a static thing and is a layered set of technologies and operational aspects as well, right? So, you know, stealth is not about, or survivability is not about being invisible. It's about disrupting enemy kill chains, which can be done through signature management, right? It can be done through EW, as Kooler pointed out. It can be done, as I'm sure the F-22 pilots are very aware, by how you fly and engage your airplane in TTP as well, right? So there's a lot to it, and it's going to have to continue to evolve. So, you know, how do we stay ahead? First thing, you know, as General Voorheis pointed out, we stay very close with our development customers and our operational customers, and we understand where the threat's going. We have the ability now to come up with incredibly accurate models in terms of predicting the stealth signatures of the aircraft we build, to where, you know, you take the experimental bug slat and lay it down on the theoretical, and it's, you know, almost looks like carbon copies, right? So we have the ability to model threats very well. We have the ability to model the technologies that we put together in here, which help us stay that step ahead. We don't always have to experiment in order to figure out how viable a new survivability technique is. We can model it, and then, of course, we spend substantial R&D, capital money every year investing in all the things that enhance survivability. That's materials, as manufacturing processes, right? The signature of your aircraft is very dependent on how well you're able to actually buy it. It's the software that goes into the system. It's a flight control system. So enormous amount of money, informed by the collaboration we have with our partners and customers in the Air Force as to where the threat's going, the ability to model it, and then investing proactively and aggressively.
Very good, thank you. Dan, let's chat a bit about the F-47. I mean, I'm sure it's something that you're looking forward to doing. It's going to operate as part of a family of systems. Now, you know, unfortunately, the specific elements are largely classified. That's okay, but we can talk about the macro level concept. In an era of tight budgets, programmers will go after parts of the enterprise. So to that end, could you talk a bit about why it's crucial that we acquire all the parts of that family of systems?
Yeah, thanks for that question, and thanks for having me here today. Really excited to be talking with all of you. In America's history of air dominance, going back to the P-51 and the F-86 and the F-4 and the F-15 and the F-22, it's always been a family of systems concept. And when a new platform comes online with game-changing capability at the time, two things happen. One is that makes a real difference for the warfighter in the fight. And the second is that the system around it learns and adapts and evolves, and the whole team, the whole family becomes a lot stronger. So that is something that's happened over time. What's different now, the technology is very different, the threat is very different, and the teaming is very different. And my sincere compliments to General Voorheis and his team for the radical teaming approach we're taking on F-47 to make sure that we get the technology part right, both with how we're designing the airplane and what's on the airplane, to address the threat. And that's going to have to evolve at a pace that we haven't seen before. This is where government reference architecture comes in, and fully embracing government reference architecture means that platforms can evolve and change at a much different rate than we've historically known. And that means that that whole family that's adapting around the thing that's changing is going to happen at a rate that we've never seen before, and in a multi-domain way. Space layer, air layer, all together. You have to have all those pieces to have that family be able to operate that way. Certainly, products like B-21 and F-47 have to have awesome stand-in organic capability, but the whole system is strongest when it evolves and learns together. And that's why we're excited and honored to be building and delivering that F-47 for the Air Force, and we're excited to see what it does for the family when it comes online.
Very good. Now,
Dan, just to add to that, it's appropriate we have both of you up on the stage, Tom and Dan, because I think a lot of times we talk about the F-47 family and then the B-21 family, but you referenced the highly contested environment, and what we really need to get to is a DAF family where all of that plays together, and I 100% agree that the open architectures is what is going to allow that interoperability between even our own assets, let alone our foreign partners.
I'd also throw in there that in order to be able to do that, we need to assure that we have connectivity. So assured connectivity is part of the picture. And don't worry, I'm not going to tap anybody to give us an update on where we are with JADC2, but that's something that's also part of the family of systems. Solo, we're going to come back to something that you're familiar with. In a pure fight, we got to maintain pressure on our adversary. And it's no secret, I mentioned it at the beginning, that our inventories are too small today and they're programmed to get even smaller. So how do you envision the use of CCAs, or do you envision the use of CCAs to compensate a bit for some of these force structure deficiencies, or do you hold out any hope that we're going to see an infusion of resources that are going to allow us to build back up our force structure?
I think it's probably both. And let me answer the fiscal question first. And fiscal constraints don't change what it takes to win, so we got to be clear-eyed on that. And in any future fight, the air domain is going to be key to winning. I think you can lose in the land domain. I think you can lose it in the maritime domain. But if you want to win the fight, you're going to win it in the air domain with support from space. Right. Now, let's go on to the CCA question. Yeah, I think CCAs are part of this mass discussion, and they will be. But I think there's another portion of CCAs that provides additional benefit that is often overlooked. And that's that in this next fight, or in any future fight, the ability to adapt very quickly and then scale is going to be important as well. And sometimes we get ourselves locked in generational capabilities, and we hold on to those capabilities potentially for too long. And I think CCAs and the price point on CCAs and keeping simplicity as part of that model will help us to adapt and then scale new capabilities, much like we did in the Century Series from long ago. So we'll be able to develop not only new capabilities, but then build the capacity as well. I think that's one of the benefits of CCAs that we're going to find here in the future. I do think that if we have a coherent warfighting story and we connect the operational side of the Air Force to the business side of the Air Force, and we talk through how the Air Force with our joint partners can win, that there will be an infusion of cash in the Air Force. If the strategy has changed, the resources got to follow, and I think we'll see that.
Yeah, I mean, I'll just keep beating the government reference architecture drum, because I think you can look at capacity from a couple of different perspectives. One, within the Air Force, but also from an international coalition perspective and a joint perspective. I'm very optimistic about the government reference architecture movement and the adoption that we're seeing with our Navy friends, our Army friends, and even the Marine Corps. And there's a very hungry appetite for the reasons that we, see a lot of promise in CCAs for procurement in our coalition with our coalition partners. And again, to the degree that we can be interchangeable and interoperable as a function of those architectures by design, we get an inherent level of capacity, not just in operations, but also in production, as we get possibly distributed production lines, so that when we do have a conflict, we're able to surge, not just from one contractor, but potentially multiple.
Yeah, in the future, keeping the architecture the same allows you to scale much more quickly than you have been able to in the past.
And I'm just going to jump in here too and emphasize the international partnerships. If you go back to WW Desert Storm, we had like 34 coalition partners, and they all contributed, okay? But guess what? We had so many resources that it was nice that they participated, but we could have done that by ourselves. Today, that's no longer the case. And because of the situation we find ourselves in, the interoperability and the working with coalition partners is absolutely an imperative to be able to fight and win in any portion around the world. Okay, let me switch to our industry panelist a bit. We all know the challenges the Air Force has faced for too long trying to rapidly insert technology updates. Whether discussing old software architecture, vendor lock, or contract vehicles, agility's pretty tough. So what are your thoughts on how we can do a better job of rapid capability incorporation? And Kooler, why don't we start with you, and then we'll go to Tom and Dan.
You don't know this right now, but there's like 15 BAE executives here cowering at the thought that I'm an industry expert. So.
Well, hey man, you got the suit.
I know, right? It's still blue though. The ability to go fast, it goes to what General Voorheis was talking about. It's the ability to have a known thing that you can write to and software update. You've got to have the right hardware that's versatile enough to accept any software on it. And you've got to be able to iterate in that process. But the other thing is we've got to be able to take a little bit more risk. We've got to be able to go, hey, here's the 80% solution. And I would tell you that my company is the best at solving the corner case. You want the wicked hard problem solved, BAE will get after it for you. But what we know is there's a bulk of this that we need to get after first, and that desire for just perfection elongates acquisition cycles, elongates testing. We've got to be able to do this really, really rapidly. So the right hardware with the software that can be run, any algorithm from anybody, right? So if you have a EW system, and Northrop has a great algorithm, we want to be able to run it, right? Same for Raytheon, L3, you name it. We've got to be able to work together on the things and to be able to do it fast.
Good, sir.
Yeah, I think jumping on, a couple of the things General Voorheis mentioned before are the open architectures and the digital models, I think are huge changes. I was thinking this morning as I was looking over, kind of the notes of things I wanted to cover about the open architectures. I don't think we can underestimate the importance of the advancement of software technology over the last 20 or 30 years. What's that done to our ability to have open architectures? I started off coding signal processing software in the early 1990s. I literally had to count clock cycles, and if I couldn't do my work in time, I had to code it in machine language, right? That's not amenable to open architectures, but that's where we came from, and that's, believe it or not, there's probably still systems in use today that have code that was written back then like that in there. But we're beyond that, right? We've got to the virtualization of machines, containerization, all those things lead to open architecture, and it's great to see both the DAF, promoting this general architecture and open interfaces, and that industry is responding positively to it. We just had a meeting with the media earlier on today about the Beacon project that we're doing. We're teaming with 6 different new entrant artificial intelligence companies that go and experiment on an optionally autonomous aircraft very, very rapidly. And we expect to be flying all 6 of those AI autonomy solutions in less than a year. Okay, so that's what open architectures brings you. In terms of digital engineering, I'll just point to B-21. We've had, I think, really phenomenal success to date in the flight test campaign. We just flew our second test aircraft first time a couple weeks ago. We've already had a second flight on that. We're able to cover basically the first flight of T2 covered the equivalent test space that T1 took 4 separate test flights to do, right? So we're accelerating, we're flying regularly. It's because those digital models, and General Voorheis, you remember this when we were, as you mentioned, partnered in development, are very, very good at helping us burn down risk and project performance. So we're short in time. I don't want to take all of it. So Dan, why don't you jump in?
Tom, I agree with you on the technology piece for sure. I do think that the other part of open architecture is about the persistent competition and breaking vendor lock. And so I am seeing the whole industry respond with this persistent opportunity to get on platforms and to bring their content to bear, which I think is great. The technology is a huge part of it. I really do think the teaming piece is the other big part. And General Voorhees talked about acquisition reform. I have been so impressed with how the Air Force has embraced active management principles and is bringing that with industry together to solve problems at a pace that I have not experienced before. And that really centers around getting focused on what the warfighter needs. And then you have all the stuff that you're doing in the normal course of a program, and you have to stop and make sure it's actually making sense and it's actually delivering what's needed on a timeline that's relevant. The technology is there. Active management is having the leadership courage to pivot and go fast in a direction to get something done and delivered. And I think when you take the technology and the active management teaming approach and put them together across multiple platforms, you're going to see a drastically different effect. That's, I think, really cool. And we'll talk a lot about the technology. I don't want to lose the teaming aspect, because that's going to make it happen.
I'll just add from an open architecture perspective, and as we get more into software-defined capabilities, an area where we're going to have to partner and active manage through that is new business models for how do you drive innovation in a place that encourages both traditional and non-traditional and newcomers to come into this space and want to sell software capabilities and software skills to our programs.
I think that's an excellent point. And right now, we see industry responding, believing that's going to get figured out. Certainly a lot of the new entrant companies I was with this morning. But it's something that we do need to figure out, or if we can't find a way of making it worth these companies being in business developing software, they're going to go to other applications. So thank you for mentioning that.
Yeah, this is a little bit off script, but as I'm standing here listening to you, I would be curious about how artificial intelligence fits into this whole area that you're talking about. And if you have found it useful yet today in accelerating some of the topics that you just hit upon.
Yeah, it is useful today. And it's whether it is making a difference in how we work in our factories or how we code. I know, cognitive EA and some of the ways we're going to think about how to address threats in real time, it is making a difference every day. And I think we're at the very leading edge of what that's going to do for us. I think that and the open architecture concepts we've been talking about, it really all marries together. And we really just haven't got our heads around how fast we can go and how much learning we can multiply across the system through AI tools. But it is definitely making a difference today. It's real today. It is in your products today. It is happening in real time.
Yeah, I mean, we're seeing AI being used across the spectrum, and I think what some people miss is there's been elements of AI in products for a number of years. I mean, it's, believe it or not, way back in the day, my graduate degree was doing machine learning and neural networks, right? Again, the pace of technology has now enabled that to be much more powerful, used much more widely. So we've gone from the area of kind of the esoteric application of it through the 90s, the 2000s, 2010s to now you have AI specialists. My belief is that eventually AI is going to turn into just another tool in the engineer's tool bucket, and it's going to be, do I use a Kalman filter for this, or do I use a neural network, or how do I approach that? So I think we're going to see it coming more and more into the mainstream to solve problems.
And folks are a lot more comfortable applying it and using it. Yeah. Kooler.
They're not only comfortable, I mean, we're seeing this in Ukraine. They're using AI to analyze the battlefield, change the algorithms that they're using, and go out the next day. And so what we see at BAE, you know, we've had, like Tom said, we've had AI in many of our products still today, but what we know is the incredible amount of data that we're going to have to process across the battle space. There's no way a human being can do that. And so using these tools are going to be the way that we stay ahead of our adversaries.
Yeah, we talk a lot about acquisition reform from a process perspective, but I am very optimistic about the application of AI, for example, in the test environment, the ability to quickly and at speed exploit our mass amounts of test data to get better insights faster, to get through the test program faster. And that's just one area of application, I think, in our acquisition enterprise.
Very good. Tom and Dan, we think long-range kill chains are going to offer some critical options to boost combat effectiveness. And, you know, Mitchell, we're big fans. However, we're also aware that China specifically worked to degrade and disrupt our connectivity. Given this context, why is it still important that aircraft like the B-21 and F-47 have the ability to close their own kill chains through all the elements that are required?
You know, again, I'd point to Operation Midnight Hammer. Sometimes you just have to be there to get the mission done, right? And like you said, if these complex long-range kill chain networks that drive that are degraded, we still have to provide the warfighters the capability of accomplishing their mission. Dan?
Yeah, I agree there. Organic kill chain closing is essential. And it's an imperative that the U.S. Air Force maintains that ability, and platforms like F-47 and B-21 definitely get you there. It's a survivability thing that Tom talked about earlier. It's not stealth, it's survivability. And we're going to have a tough fight, and we're going to get punched and hit, and we got to be able to punch and hit back in position. And then as we restore and maintain the big family of systems that's out there, capability goes back up and up and up, and that's how we sustain and win a fight. But you have to have both those things, and you have to be able to maintain both those things.
Yeah, I think you have to have both a long-range kill chain and the ability to have an organic kill chain. You want to maintain operational initiative despite conditions. And there's going to be times when long-range kill chains are down, and you're still going to want to be able to take the fight to the adversary, and we need to. I think we need to think about how we integrate long-range kill chains and organic kill chains. I know, as fighter pilots, we have a weapon select switch on our throttles, and you push it forward, it gives you a medium-range missile, and you pull it aft to the middle D10, it gives you a short-range missile, and you pull it aft even further, it gets you guns. It's a really, really seamless way to switch between kill chains. I think eventually you'll see us get to this point where we're doing that with long-range kill chains and our shorter-range kill chains, where the ability to very quickly switch between long-range kill chains, which are absolutely necessary, and organic kill chains is something that's just going to be something we do, and it becomes easy. I also think there's something to what I'll term JDAM Day. You want to get to JDAM Day where you can get to weapons that are cheap and you can employ them in mass. If you are stuck solely with long-range kill chains are going to be exquisite. The sensing is going to be exquisite. I'd say long-range kill chain, the weapons are going to be exquisite. We are looking at affordable long-range weapons, all right? And they'll be part of this mix. But we've also got to realize that the kill chains are going to be more difficult. And if you can unlock the arsenal of direct attack weapons, you're going to find yourself in a place where you can attack the adversary more frequently, I think.
Okay, good timing, Solo. To wrap this up, this is for each of you. You have a minute each. And I think it's important to highlight the costs involved with failing to have modern air power. Our example here is looking at Ukraine. What has that conflict taught us about the importance of possessing 5th and 6th generation fighters, CCAs, and electronic attack, plus the world's most advanced bombers and electronic attack aircraft? We'll start with Solo, and then we'll go down the line.
I thought I was going to have 5 minutes to think about this.
Thanks for throwing me a bone.
We just get to say what he said.
Exactly. So, hey, there's a lot to be learned about Ukraine, okay? And we've also got to make sure we don't learn the wrong lessons. What I would suggest for Ukraine is we don't want to over-optimize for a certain theater or a certain war, okay? I think we need to create a force that has flexibility in it. I do think that there are some fights in this world that don't resemble the Ukraine fight. And you can bet that we are planning for those fights that are going to be much more complex and require range and require long-range kill chains and require a mix of capabilities. That's what I think that we're learning from a force design perspective. Don't over-optimize in a single scenario. Make sure you have a flexible force.
Very good. Dan?
This isn't a sexy answer here, but availability is a real warfighting capability. And I think with all the high-end weapon systems we're putting together, all the weapon systems we're putting together in this new digital age, we still have to be able to support it, and we have to be able to train to it in order for everybody to employ it effectively. And so that's helping us really refocus on making sure it is simple and straightforward, and we have a good support approach for it from the beginning.
Following on the general's point, there's a great article I'd highly recommend a lot of people read. It was in Daily Blast a couple weeks ago by a Ukrainian tech executive here in the States talking about what lessons to learn and what lessons not to learn from Ukraine. I think one of the things that sunk in on me the most looking at the warfare in Ukraine is the rapid innovation cycle. And it's not just that we have to be able to rapidly innovate. We need to be able to scale that innovation like that. Because if we're able to come up with an innovation that gives our warfighters a tactical advantage, we have to understand that at the rate innovation is going, there's going to be a countermeasure to that very, very quickly. So we need to get that innovation scaled across our platforms as quickly as possible, which goes to open architecture's ability to upgrade and test rapidly, right? And if we can do that, we can get the most tactical advantage out of every innovation. If we don't, we just go, that was really cool. Too bad we didn't get to use it more before there's a counter developed to it. So that's my takeaway.
I think the answer is harumph from what you guys have said. But look, the lessons from Ukraine are if you don't establish air superiority, you're not going to win. Just what you said, General Deptula. And all the lessons learned, the rapid reprogramming, the use of drones, all that is really essential for us to understand. I would say that the lessons from what has been done to Iran emphasize the fact that you need that blend. And what we saw was a blend of capability that went in. But I would say that one of the most important things that we sometimes don't talk about in Ukraine, I think the biggest reason for the failures that we've seen from the Russian forces, they never trained together. They don't have a joint force. They have an army, and they have a navy, and they have an air force. They don't know how to fight combined. And that's what our warfighters do better than anybody. So that training of the joint force to present that to the combatant commander to go against our adversaries, I think is key.
Yeah, so adaptability, agility, scale, jointness, coalition warfare, 100% agree with all of that, and that open architectures is at the foundation of that. The Air Force has been putting a lot of effort into government reference architectures and really trying to develop an enterprise approach to that so that we can all skate to the right puck. And so with that in mind, and in the context of AFA, with all of our industry partners here, just a huge kudos to everybody for the dialogue and the discussion, for helping us drive towards that as a Department of War, as a nation, versus sitting back and waiting for RFPs to come out, but really taking that to heart and driving it with your IRAD, driving it with the product development that you're doing, so that we all get to the place we need to get to, which is a system of systems ability to fight, as these gentlemen here have talked about.
Well, thank you, gentlemen, for a great discussion. And to all of you in the audience, we wish you a great Air and Space Power kind of day. Please join me in thanking our panelists.